Okay, today's lesson is all about interpreting parabolas and quadratic graphs. So picture a dolphin jumping in and out of the water. This graph represents the dolphin jumping out of the water, then back in the water. The dolphin is under the water and then jumps back, turns back around and jumps out of the water and back in the water. Okay, so things to consider would be the height. So your y-axis is the height. And time, so this is height with respect to time in seconds. And this is over a 24-second time span. The turning points, so we have 3 turning points here. When the dolphin jumps out of the water and turns to go back into the water. When the dolphin is underwater and then turns back around to jump back out of the water, and the repeating of turning to go back into the water. So jumping up and down and up and down. And the sea level is the last thing. So the sea level is the x-axis, and this is where y equals 0 at the sea level, because that's when the dolphin comes in and out of the water. So what can we say about the actions of the dolphin between 0 and 6 seconds? So the actions of the dolphin from between 0, because we're on time, so we're looking at the x-axis, between 0 and 6 seconds right here, we know that the dolphin jumps out of the water and takes 6 seconds to jump back in, to go back in. Okay. Where do we find the values of f of t equal to 0? So now f of t, you have to remember that f of x equals y. We learned that in integrated algebra. F of t is the same thing as saying f of x. So since f of x equals y and f of t equals y, then f of t equals f of x, f of t then equals y. And we know that y is sea level, so y equals 0. So where on sea level is y 0? And what is that time value? So we know the first one is right here. This is when the dolphin leaves the water in the beginning. So the time is 0 when the dolphin leaves the water, and then the dolphin re-enters the water at the time of 6 seconds. So we know f of t is 0 at that point. And then the dolphin swims underwater and the dolphin jumps back out of water at one time of 16 seconds. So f of 16 also equals 0, and then jumps back into the water at 24 seconds. So all of these values are when f of t equals 0. Letter C, how long does it take? How long was the dolphin swimming underneath the water in the recorded time period? So this is just basically if you can interpret that the dolphin entered the water at this point at 6 seconds and then dispersed to jump back out of the water at 16 seconds. So 16 minus 6 is 10 seconds. The letter D, estimate the maximum height in feet that the dolphin jumped in the recorded 24-second time period. So we see that there's 2 maximums because there's 2 vertex points outside the water when the dolphin jumped out of the water. But the highest one is the second jump. This is jump number 1, jump number 2. The second one is the highest. So we notice that the height of that jump was somewhere between 20 and 25 feet. So we can say approximately 23 feet high. And the last one, letter E, locate the point on the graph where f of t equals 50. So here is where y is negative 50. Notice that we are at 11 seconds, so the coordinate is 11, negative 50 in respect to the context of the problem. The dolphin at 11 seconds into its swim was down 50 feet below sea level. So that's what we can state for the context of the problem.